So last time we were together, we learned how anions like F minus react with water, H2O, to extract that H plus, and now is a base to make HF and OH minus, making the solution basic. So anions make the solution basic. Now let's look at cations. Cations are positive. For example, Na plus is a cation. Na plus will Na plus react with water. Okay, so will OH minus be extracted from water? Because Na plus and OH minus is the only negative ion in water. That won't happen because NaOH is a strong base. It'll break apart. They don't want to be together, so nothing happens. Okay. Another cation is if they have an acidic proton, like NH4 plus is a cation. It has an extra proton. So NH4 plus in water, the H plus will go into the water, making the NH3 left over. Oops, NH3. That's NH3. And H3O plus. Okay, again, another way of writing H3O plus is H plus. So it's pretty much dissociating into NH3 and H plus. Okay, so cations with acidic protons like NH4 plus will make your solution acidic because you have H plus. Now, cations like calcium plus 2, strontium plus 2, and barium plus 2, you know they're strong bases, right? So you are not going to extract the OH, two OH minuses from water, from two water molecules, because BaOH2 is a strong base. So that won't happen. Cations of strong Arrhenius bases, like BaOH is a base, NaOH is a base, LiOH is a base. These are all strong, so they won't come together. They'll break apart, so nothing will happen. So group 1, of course, group 1 hydroxides and Srbaca hydroxides are strong bases. So calcium plus water will do nothing. So because you can't make CaOH2, which means it'll be neutral. Okay? Next, metal cations. An example of a metal is iron. To make it a cation, you put a plus charge. It can be plus 1, plus 2, plus 3. The higher the charge, the more powerful it is. Okay? So, do you think if you have Fe plus 3 ions in water, do you think it'll be acidic or basic? So let's look. So let's say that I have FeNO3, iron nitrate, and the salt is a salt, because you have this is plus 3, this is minus 1, so it'll be FeNO3. When this comes apart, the Fe, you get the ion Fe plus 3, and you also get the NO3 minus. So you have to think, will NO3 minus react with water to make HNO3? No, that's not going to happen because HNO3 is a strong acid. That won't happen. Will Fe plus 3 react with OH minus of water and make FeOH? Okay, let's see what that happens. Over here, you have a picture of Fe plus 3 right here. Noticing it's positive and it's being hydrated by all these water molecules, okay, because of the attraction. What the Fe plus 3 will do, because it's positive, it will pull electron density this way. What it does is it makes this bond weak, pulling the electrons towards the O and allowing the H to leave. So it'll make the Fe plus 3 will make the solution acidic. Okay, so here's an example. You have Fe with H2O, 6 of them. 1, 2, 3, 4, 5, 6. H2O 6. The Fe has a plus charge of plus 3, so they put it out here. So this whole thing, this has a charge of 0, this has a charge of plus 3, so the total charge is plus 3. okay? Because the Fe plus 3 pulls electron density towards it, the H plus comes off. So what's left over are 5 water molecules, 1, 2, 3, 4, 5, there's the 5, and it will attach to the OH, allowing the H plus to leave. The OH minus, there it is, allowing the H plus to leave. Okay, so now you have a low pH and it'll make it acidic. Okay, and the note is the bigger the charge, if it's a +1, a +2, or the +3, the higher the charge, the more acidic it will become because it'll pull more electrons to itself. Okay, I wrote all that here. It says Fe plus 3 pulls electron density, allowing H plus to come off. So Fe plus 3 is acidic in water because the H plus comes off. And this shows here if it's a +1, it's a weak interaction. A +3 will be a bigger interaction. So the ability of this to leave is not as much as the ability of this to leave. So this H will be a more acidic proton. This will be an acidic solution. Okay, so here's an example problem. Determine whether the salt solutions are acidic, basic, or neutral. The first one, barium, letter A, Ba, you're going to have a salt because it has a plus. This is a barium is a +2, and acetate is a -1. That's why you have 2 of them. So you have Ba plus 2 as the ions. When this whole thing goes into water, it breaks into 2 pieces, 2 ions, Ba plus 2 and CH3, COO minus. Okay? Will these hydrolyze? Will it react with water? Okay? Will this react with water? Will this hydrolyze? Okay, let's see. If this reacts with water, it's going to attach to, it's either going to attach to the H plus of water or OH minus of water, okay? Since Ba is +2, it's going to attach to the OH minus. So we will make BaOH2. Because Ba is a +2, OH is a -1, plus 2H plus. No, scratch that. I'm sorry, that's right. Okay, so look at the product. Because that's a strong base, you memorize that, they want to break apart. They want to break apart. So it won't happen. So this is not going to happen. Put a big X and say nothing will happen. This will be neutral. Okay? So let's look at the next problem. This will extract the H plus to become CH3, COOH plus OH minus. Okay? Because the conjugate, this is a weak acid, that means the H does not want to come off. So the H wants to stay. So this will happen. And your solution will be basic. So if you add BaCH3COO or barium acetate, it's called, your solution will be basic. And it's basic not because of the barium +2 will do nothing, but it's the acetate ion that causes it to be basic. And this is the equation that proves that. Okay, try doing these problems on your own. Okay, let's try B. You have 2 ions, NH4 plus and Cl minus. NH4 plus and Cl minus. You add water to both of them. Will it hydrolyze? Okay, adding water means hydrolysis. So the H plus goes to the water and you make H3O plus which is the same as H plus, okay? And you're going to have NH3 left. So this is the same as H plus. Okay, this will happen, which means your solution will be acidic because of the NH4 plus. You have an acidic proton there. Okay, let's try the next one. Will it make HCl and OH minus? No, you can't make HCl. It's a strong acid. They don't want to be together. So this will be neutral due to this ion. So this together, because they come as a salt, the NH4 plus part of this salt causes this whole solution to be acidic. Okay, let's try C. CH3, NH3. Okay, this is a little bit confusing. And you have Br. You know Br is a -1, right? Which means this whole thing is a +1. Okay, and let me tell you why. Let me draw it over here. So there's the N again, okay? Normally N looks like this with 3 items attached to it, right? The CH3 is attached to this side. There are 3 H's. One goes here, one goes here. Where's the other one gonna go? It's gonna go here. Which means this substance has a +1 charge. And Br has a -1 charge. Okay, so the trick is here, if you see N and you see that there are more than 3 things attached to it, there are 4 things attached to it, CH3 is 1, and then 3 of these, that's 4 total, it'll have a +1 charge, and this proton is acidic. Okay, it'll come off, and you have a acidic solution. So you're going to hydrolyze these. The H plus goes this way. You're going to make H3O plus. Again, same as H plus. Plus CH3 and H2, which now has the 2 dots above it, and now it's neutral. Okay, but because you made the H plus, it'll make the solution acidic. Now the Br minus, to hydrolyze with water, you should make HBr, leaving OH minus, but because you can't make HBr, this will not happen because it's a strong acid. It'll break apart. They don't want to be together. So nothing will happen. Erase all this. Just cross it out. Make sure that they know that you know it's not going to occur. So this will be neutral. Due to the Br minus, together as a salt, it'll be, and you put that in water together, it'll be acidic. Okay, let's try D. KNO3, oh, there's a lot. K plus, NO3 minus. You add water to both of them. You add water to both of them. Are you going to make KOH? No. KOH is a strong acid. A strong base, so you won't make that. Are you going to make HNO3? No, that won't form. It's a strong acid. So neither of this will happen. No. So this will be neutral. So if you put KNO3 in water, just like you put NaCl in water, it'll be neutral. Okay? Last one. Letter E. So you have AlClO4. Okay, so here we have, I should write it. Al is a +3. The reason I know it's a +3 is because it's bounded to ClO4, which is a -1, and there are 3 of them. Okay, so this has to be a +3. And ClO4 -1. Okay, hydrolyzing those with water, H2O, H2O. You're going to make the H will go in and make HClO4. And you know that HClO4 is a strong acid, so that won't happen. Nothing will happen there. And then this, I'm just not putting the other side, so it's KOH plus H plus here. I'm not writing that because it's not really important, because it won't happen anyway. Okay. Now the aluminum. The aluminum will become Al with some water. Now, so I'm going to say it'll bond with the OH. It'll get rid of one of the H's. Okay. Since this is plus 3, you can just say plus 3 minus 1, put 3 of these. It's fine. Plus, you're going to be able to give H pluses on this, a bunch of them, 4 of them. You don't have to write that. All you have to know is that it gives the H plus. You can put 3 if you want. That's fine. You can put 3 here if you wanted to balance it. And you just made an acidic solution. So this will be acidic. AlClO4 will be acidic.